All right, we're starting back up with our video lessons, and we're going to start in Chapter 6, Properties and Attributes of Polygons. Hopefully you'll remember what a polygon is. Okay, a polygon's a closed plane figure with 3 or more sides or line segments. It just means, just remember, it has to be closed like this. It has points, which are called the vertex. It has sides or line segments over here, which are called the sides. And it also has these line segments that go from one vertex across to another vertex, and those are called diagonals. Okay, so hopefully you remember the number of sides determines the name of a polygon. So 3 sides is a triangle, 4 sides is a quadrilateral, 6 is a hectagon, 8 is an octagon, and you remember all of this. So here's a quick example. It says to tell whether the figure is a polygon. If it is a polygon, name it by the number of sides. So we look at this first shape, we see that it's closed. All the sides are line segments or straight. So we can say that yes, this is a polygon, and we would call it a hexagon. Next shape we see, all of the sides are straight, they're all line segments, it's closed. So yes, that's a polygon. It has 1, 2, 3, 4, 5, 6, 7 sides, so that makes it a heptagon. We look at this little moon-shaped thing, and it is closed, but the sides are not line segments, they're curves, so this is not a polygon. Again, this one is not closed, so not a polygon. This one is closed, and it has line segment sides, and it has 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 sides, we look up here, 9 is a nonagon. So we say yes, it's a polygon, and it's a nonagon. And then this last one over here is a no because it doesn't have a line segment side. Okay, and just like you learned about equilateral and equiangular triangles, equilateral polygon is one where all the sides are congruent, and an equiangular polygon is one where all the angles are congruent. And we say that a regular polygon is both equilateral and equiangular. Okay, so that's what word goes in here. A regular polygon, remember equilateral, equiangular, means all the sides are the same and all the angles are the same. A polygon is concave, and there's some typos here, if any part of the diagonal is outside of the polygon. So if we looked at this picture over here, when we connect from one vertex to the other vertex, we connect this diagonal, well, it's outside of our shape. And another way to remember it is if you see one that's caved in, then it's concave because it's caved in. Polygon is convex. We can scratch all this out. This is all a typo. Somebody just copy and pasted this. If all the diagonals are inside the polygon. So it's real easy to remember. Just remember that if it's caved in or dented in, it's concave. If it's not, it's convex. Take a look at these examples and tell whether these polygons are regular or irregular, and then tell whether they're concave or convex. So first one, regular means all the sides and all the angles are the same. Well, these two angles are not the same, so this is irregular. It's not caved in anywhere, so it's convex. We look here, all these angles look the same, but all the sides are not the same, so it's also irregular. And you can see all these corners are caved in, so it's concave. We get to this one, we have a square here. Even though it's turned funny, it's still a square. We have all 4 sides are the same, all 4 angles are the same. That means it is regular. It is not caved in, so it's convex. 1, 2, 3, 4, 5 angles the same, 1, 2, 3, 4, 5 sides the same, regular, another convex. Now we look, we have two sides the same, and then two other sides that are not the same as those first two, so that makes it irregular. And it's clearly caved in right there, so it's concave. Okay, something you worked on in class was figuring out the sum of the interior angle measures of a polygon. And the way we did it was by splitting those polygons up into triangles. So a triangle, we know, adds up to 180 degrees. Well, any quadrilateral can be split into two triangles that both add up to 180 degrees. And what you discover in your activity today was that as you keep going and adding sides, you're also adding the number of triangles that you can split this shape up into. Okay, so if we remember our triangle sum theorem, it says that the sum of the interior angle measures of a triangle is 180 degrees. So if we have a triangle, it has three sides. That makes one triangle, and its angles add up to 180. Well, a quadrilateral has four sides. That's what's in this picture. Makes two triangles, and we know that that adds up to 360 degrees. And if we keep following along with that pattern, five sides over here, a pentagon makes three triangles. 3 times 180 is 540 degrees. And then we have six sides, a hexagon right here in this picture, makes four triangles. 4 times 180 is 720 degrees. So we kind of see this pattern that if we subtract 2 from the number of sides, that tells us the number of triangles. And then we multiply that by 180. That gives us the sum of the interior angle measures. So when we talk about an n-gon, we're talking about a polygon that has any number of sides. So instead of saying it has 3 sides or 4 sides, 5 sides, we're going to say it has n sides. So the same pattern would apply here, though, to find out the number or the sum of the interior angles for a polygon of any number of sides. You would just subtract 2, see what it equals. Well, n minus 2 equals n minus 2, and then you would multiply it by 180. And to kind of clean that up, the sum of the interior angle measures of any polygon is n minus 2 times 180. And that will give us the sum of those interior angles. So we're going to kind of formally write down what that says. That's called the polygon angle sum theorem. And it says that the sum of the interior angles of a convex polygon with n sides is n minus 2, so number of sides minus 2, times 180. So, quick example, find the sum of the interior angle measures of a convex heptagon. Well, heptagon is 7 sides, so that means n equals 7. So to find the sum of the interior angles, we're going to do n minus 2 times 180. So we'll do 7 minus 2, because it's 7 sides, times 180, which is 5 times 180, which is 900 degrees. So all heptagons that are convex have an interior angle measure of 900 degrees. Okay, find the measure of each interior angle of a regular 16-gon. Well, that means that n equals 16. But the difference with this problem is it says find the measure of each interior angle. Okay, so you have a 16-sided shape, and we want to know what each interior angle's measurement is. Now, because it's regular, that means they're all the same. So we don't need to find all of them, we just need to find one of them. And the way we're going to do that is we're going to find what all of them add up to, and we're going to divide it by the number of sides. So we do n minus 2 times 180, which is 14 times 180, which gives us 2,520 degrees. Okay, that's the sum of the interior angles. Now if we divide that by 16, because there's 16 sides and 16 angles, we're going to get 157.5 degrees. So that's what each angle of a regular 16-gon would add up to. Okay, so remember, an exterior angle is formed by one side of a polygon and the extension of a consecutive side. So if we have a triangle that has one of the sides extended, this is the exterior angle. Now, the polygon exterior angle sum theorem means what do the exterior angles add up to? The theorem says that the sum of the exterior angles of a convex polygon is, and this is an easy one, it's always 360 degrees. And I'll show you more in class as to why that's always true. But to find the measure of each exterior angle of a regular 20-gon, so that's n equals 20. How would we find each angle? Well, if we know that they always add up to 360 degrees, we just take 360 degrees divided by n. So 360 degrees divided by 20, and that equals 18 degrees. Remember, each exterior angle, that's each one of these, right? Each one of the exterior angles, and they always add up to 360. All right, so let's take a look over here. Find the value of b in polygon FGHJKL. So FGHJKL. So to find the value of b, we need to take each one of these angles, right? Take all of these angles, and we need to add them up. And when we add them up, they should all equal something. So 33b plus 16b plus 10b plus 28b plus 15b plus 18b. So we add all those up, right? We added all those angles up. They should equal 360 degrees. Okay, so when we combine all our like terms, we get 120b equals 360. Divide by 120. And we get b equals 3. Now, all it told us to find was the value of b. If we needed to know the angles, we could plug the b back in. And if we did plug b back into each one of these, we would see that they all add up to 360 degrees. So that's it for tonight. See you tomorrow.